A very warm welcome to our listeners to the IQ Business Artificial Intelligence podcast. We've missed you. It's been about a month since we've engaged, and we're extremely excited today to be joined in our studio, our virtual studio, from a special guest from the UK today, Houston, who will be introducing himself in a few minutes and telling us about his journey in AI as well. But fantastic to have you all back listening to our podcast. We're very excited to be talking about some of the practical use cases and challenges around scaling artificial intelligence in the workplace. But it's been some time since we've spoken to you, so we thought we'd just do a quick roundup on all things in the news. Josh, feel free, or Houston, to jump in as you see fit here. But I think the first bit of media that's really hit my eyes, obviously, been this news that Mustafa Solomon has joined as the new AI chief for Microsoft. We spoke about Mustafa some time ago. He was the author of The Coming Wave, and I think quite a visionary in the AI space. But what do we think this means? I mean, this is interesting now that Microsoft have got both their connection to Sam Altman and to OpenAI, and now they've also got Mustafa Solomon.
What is very fascinating for me is exactly what you said. They're getting access to Sam Altman and getting access to Inflection AI. And I was actually looking at a graph today that shows all the investments that Microsoft has made. And they've made in so many different AI startups and AI models. I remember last year when we were trying to get into properly understanding what large language models can do for our business. And at that time, it was only Azure OpenAI that was available. So the OpenAI that they hosted in Microsoft. When we got access to Llama 2 when it was released, it was not accessible in Azure AI Studio. You couldn't really deploy it. And then they partnered with Llama 2. I got so confused because I thought Microsoft competes with Meta, but they are partnering with Meta to deploy this model. And after that, they get, these are the models just coming in. So Microsoft has been trying to get their hands in every pot. And then now getting him to come and be the chief for AI in Microsoft is incredible. They would have done it with Sam Altman anyway. I think after the fracas at OpenAI, I think they've been looking for someone who's a visionary in AI to come and actually lead that department. Incredible to see that they got one now.
I think it tells us absolutely that Microsoft sees the future in AI. I mean, that's absolutely where their bet in everything will be. And it also just shows us that there really are only a few key movers and shakers at the moment in the AI space. You can kind of list them off on a single page, but Mustafa definitely been one of them. And I've got no doubt that as we understand more of the detail of that deal, it will be something fairly eye-watering to move across from Inflection and all the claims of efficiency that they had to Microsoft. I've got no doubt that he'll be chartering his private jet all over the globe in the coming months. So quite an interesting one to see. Josh, also some interesting news that's been circulating. It feels like old news, but it's only about a month old. Sora. Talk to us about Sora. It's been all over the headlines.
Yeah, it's a really fascinating release from Microsoft. Sora essentially is a text-to-video model, which is essentially an adaptation of some of the diffusion models that have come out recently. The basic principle is you create a model that can take or start off from a position of noise, and from that position generate images given some text conditioning. And that was released, I think Stable Diffusion was one of the open source releases, versions of, or companies that released this as an open source technology a few years ago. But many anticipated that it's just a matter of time before we go from picture to video, because it's essentially a frame rate thing, you know what I mean, and the stability and transition between frames. And now we seem to be here, not commercially available yet, to my understanding, in preview, in sort of early access release. But from what we can see, it produces incredibly realistic videos just from some text input. So if we think about use cases here in the arts, creatively, in design, marketing, advertising, film, etc., gaming, I think it's really, I'm personally really excited to see what use cases come out of Sora. I'm not sure what you think, Houston, of those early release demos.
Yeah, 100% agree with you. One thing that you mentioned there, which is the gaming. Many people do not think exactly about gaming, but gaming is going to benefit heavily from generative AI. That Sora model, I think when it was released and Tyler Perry saw it, he was about to invest $800 million into building or expanding his studio in Hollywood. But when he saw Sora, he paused that project because these models are going to disrupt even the movie industry. When the sort of models, yes, they are generating 11 seconds of video, but as the saying goes in the AI, this is the worst it will ever be. So after this, it's going to be 20 seconds, 30 seconds, a minute. Maybe it's going to be you, Josh, creating a movie for an hour and sending to me on Teams, and I'm watching your movie that you have produced.
It's in the early stages of this boom. I spoke about the great age of misinformation that's coming. Hard for me not to think that this is going to be a tool that's going to be used by propagandists and information peddlers. And at some point, we need to have a deeper conversation about how all of this regulation is really going to work. And I know there's been some movement in the space recently as well. But really, the moment where somebody can create video that's at 4K, pretty much realistic, of all sorts of things that didn't happen, is there's obviously quite a lot of frightening scenarios there as well. You spoke about gaming. I don't want to go into too much detail here, but just interestingly, as I understand it, many of these games that have kind of simulated worlds have been built on top of something called the Unreal Engine, which was the platform that was used to create initially a game called Unreal Tournament, which is effectively a physics platform that allows you to understand how objects, polygons move across 3 dimensions of space. Do you think that that's what's going on under the hood in Sora, or do you think this is like a novel approach? I mean, I haven't read too much to say how it's actually generating out the video. I'm pretty sure it's not a pixel by pixel prediction. It must be something that's maybe trained on something a little bit more sophisticated. But anybody got any ideas of actually what's going on there?
Actually, I have no idea, because they haven't released any paper or any proper insight. And you're right. People are suspecting that it's definitely not just pixel prediction where the pixel is going to be. But right now, we actually have no idea. We're just seeing the videos come out, we're waiting patiently to read the paper.
It's really easy to be the host to just ask impossible questions and throw them out into the audience.
Yeah.
But it will be interesting to see what happens there. I did notice that in some of the Sora videos, things didn't look quite right. You sort of find yourself almost in the uncanny valley, where just some of the proportions of people walking down the streets is just something's not completely coherent. It's almost like it's a little bit dreamlike, but as you say, it's the worst it's ever going to get, and soon it'll be completely lifelike. So, I mean, underneath all of this, the other big thing is what's powering all of this AI. And NVIDIA, somebody showed me a chart of their stock price. I think it's like, it almost looks like a straight line going up. Must be wonderful to be the NVIDIA CEO at the moment, who's been making some bold statements at college campuses. But they released the Blackwell chip. And the Blackwell chip comes at quite a good time. I think it comes in response to another startup that's come out of the US, a company called Grok. And really the reason here is that the energy requirements and the efficiency gains required to power these large language models is becoming something quite serious. I think Sam Altman has invested in fusion technology as well, because it believes that the amount of energy required to power what will ultimately become AGI, we don't have it. We don't have enough energy right now to do it. But any thoughts on this Blackwell chip, or any observations there, Josh? I mean, I don't know. Are we breaking Moore's law? What do you think?
Yeah, from what I can see, with some commentary online, that it's sort of a nail in the coffin for Moore's law, which sort of anticipates almost a doubling of the number of transistors you can fit on a chip I think it's every 12 months, every 24 months. Stand to correct me there. But yeah, I mean, I looked at the sort of computational capabilities of Blackwell in comparison to previous generations, and it clearly doesn't follow that sort of pattern. It seems that we have perhaps officially broken Moore's law there, or perhaps redefined what that would look like for these new generation of GPUs and LPUs. I'm really interested in seeing what impact that'll have on, or not necessarily what impact, but what will become of Grok, the Grok with the ending with the Q, which I think is the one that developed the LPU, or almost LLM chips essentially dedicated for LLMs. And I really do encourage the listeners to look up Grok on YouTube to see an interview that occurred between a CNN anchor and the president of Grok, and a sort of almost real-time conversation between the anchor and an AI chatbot with very minimal lag. And I think that even though there is still lag there, it's a minimal, and I think that's only possible through these new computer chips. Some say it's the biggest rise in the history of capitalism. that being an NVIDIA. What goes up must come down. So it'll be interesting to see if it's just another bubble or whether maybe they're excuse the science fiction reference, the next Tyrell Corporation, which is a reference to Blade Runner, for those who are.
Or perhaps the third scenario, which is your margin is my opportunity, which is the one that I think is going to fuel the Silicon Valley ecosystem of many, many competitors coming into that NVIDIA stable. I mean, just worth noting some very high level numbers there. NVIDIA's got 35,000 engineers working on their chips and producing the Blackwell, which has come out recently, which they say is 1,000 times more powerful than their previous GPUs. That is in stark contrast to 35 engineers working at the Grok with the Q, who produce something up until very recently we thought to be the most sophisticated large language processing unit on the market. So I do still believe in the startup. I believe in the flexibility and creativity that comes out of smaller businesses, but let's watch this space. The margin's definitely going to create opportunity. I think this is the perfect segue to move into the main topic of our conversation today. It's all about scaling. It's all about the fundamentals. It seems like the wrong way. We've done this in the reverse order, but Houston, it'd be really wonderful for you now to introduce yourself. We are incredibly honored to have you here today. Houston is in the UK in AI and data at Investec. He's also the founder of IQ Mates. He's been a Udemy instructor and a head tutor at the business analytics department in UCT. But tell us more about yourself, please, Houston. And we'd love to hear about an article that you've written entitled 5 Reasons Why AI Use Cases Remain Elusive for So Many Companies.
Yeah, thanks, Tim, and thanks, Josh, for hosting me today. Actually, so to be a bit of background, I started sort of my AI journey or focus on AI around 2018. 2018, where my leader at the time, she came up and said, we do analytics, normal day-to-day analytics, data analytics, we on PowerPoint, on Excel, and all of that. But we wanted to get into the more predictive stuff. How do we build machine learning in our department, the private banking department at the time? And so for 6 months, she said, I will not give you any projects. For 6 months, your focus is coming YouTube, Coursera. That's all you're doing. For 6 months, that's what I was doing, signing in to work and doing that. And trying to...
Must be one of the few people who could get away with saying that I spend my day watching YouTube, and that's what my boss wants me to do.
Exactly. Like actually, and my access at work hasn't been taken off. People walk past my desk. Like, how did you get YouTube? I'm like, 2018. So at the time, so try to understand how to really do machine learning in a bank situation. Most of the machine learning that was there at the time, it was mostly research or ImageNet. You'd hear that, oh, there's a paper that has been released. This is what has happened. Or big banks like your Standard Banks, your FNBs, all those big banks, yes, they were doing machine learning. Or it was sold. It's a fraud model that you buy with your fraud system and all of that. So we, as Investec, we wanted to figure out how do we actually build our own models that are relevant for our client base. And so that's when the journey started, and through understanding that, and through my background in business school, because I went to business school, I think marrying the two, as they say, data scientists, they sit in between the technical understanding, the computer science part, the statistics, the mathematics, I did applied maths, and the business understanding. So bringing all those together, that has been my journey since 2018, and coming up with use cases, because I would understand, business is struggling with growing the loan book. Maybe if we apply this AI model, if we build this ML model, we are able to actually uncover new opportunities. And then from there, I just then moved over to the UK, and then in the AI and data team, still with the same type of mandate to try figure out where we can use AI to accelerate the business, whether it's in operations, whether it's in finding new opportunities, or to support our frontline sales business.
We've spent a lot of time in the last year talking to everybody from CEOs of big businesses to startup entrepreneurs to people inside big organizations. And I mean, an observation that I'd make is that we can all see this enormous potential of AI and what it promises to be. But the lived experience for most is that there are quite significant barriers to traction in big organizations. And those barriers to traction are almost, let's call them organizational cultural barriers. The inertia inherent in big systems, people being afraid of change, not understanding the relevance to themselves. I think this is possibly talks a bit to your thesis. why are we finding something which is so profound and so disruptive hard to access? I'm not seeing a lot of companies, suddenly turn off their call centers or build super next-gen models or automate processes that they couldn't automate in the past. What's holding us back? What's your experience? What's your view?
Yeah, so I'll just give 5 high-level reasons that I did write on the blog post itself. The first one is definitely access to data, availability of the data that you want. Many people that I speak to, they think in the universe of the data that they have currently. So if I'm in banking, I just think of my transactional data. I never think about other third-party data that I can bring in because I'm just thinking about the data that I have. So that is one limitation that people are thinking of the use of use cases. They are just thinking about the data that they have in their universe. They're not thinking about publicly available data like interest rates over the years. We might not have it internally, but it might be useful for us to predict which ones of our deals are going to default. So availability of the data is one of them. The second one is accessing the right talent. Some of these programs were developed many when it comes to universities. The universities only started teaching data science pretty much 10 years ago. That's when they had focused masters in data science or honors in data science, honors in artificial intelligence. I remember when I was at WITS, there was no focus for data science. It was just one part of a course and then you move on. But now they're dedicating a full year to studying that. So accessing the right talent that actually understands data science is still developing from universities. And then supporting infrastructure is the third reason that I would say. Many companies, they just do not have the supporting infrastructure to really take these models to the next level. So that includes, when it talks to talent, people who are good at ML ops, machine learning ops, AI ops, and all of that. We know it's possible, but some companies just don't know how to actually do it. How do we get someone to do the ML ops itself? So finding the right talent. And the number 4 reason is understanding limitations. It's a pro and a con of ChatGPT. When ChatGPT came, many people, like you said, we thought we are going to change the world with ChatGPT. But then when you try it and then it fails, people are not exposed to AI. They then drop. They're like, AI doesn't work. But actually, it works because people who have been exposed to AI see how it has leaped forward. But people who haven't, they're like, oh, it has promised us the world, but actually it is not conquering the world. So we're going to leave it. So understanding those limitations will help someone come up with actual use cases that move the needle and not just use cases that then, if it fails, then you don't do AI anymore. The last one is just being overwhelmed. So many things. We started off with the news. You said yesterday, Mustafa was hired by Microsoft, and that was just yesterday. Tomorrow, there's something that is coming up again. On Monday, NVIDIA released a new chip when we were boasting about Grok 2 weeks ago. So things are moving very quickly. So many people are getting overwhelmed. Many people are getting overwhelmed, and so difficult to keep up. Many papers are getting released. So it's how do you make sense of everything and come up with the use case? But we can get into more detail. But those are the 5 reasons that why businesses are finding it difficult to actually come up with proper needle shifting use cases.
I think those are really insightful reasons. And I think we should double click into them. I think the ones that really grabbed my eye, and just in the interest of time, we may not be able to deep dive all of them, but I think this availability of the right data is absolutely fascinating. The understanding of some of the limitations, we've spoken about that before, and I'd like to talk a bit more about it as well, potentially the supporting infrastructure. But if we start on the data piece, I mean, you talk about this idea that people in their domains in an organization are unable to, it's almost like a lack of awareness of what data could potentially be required to build better models. I think that's definitely one constraint, but it's very much a kind of an educational constraint, possibly informed by the way the classic models may have worked. So historically, it may have been more difficult to bring in stuff that would have been seen as like extraneous variables that didn't fit nicely inside a classic model. So kind of how do I do it? So I can understand almost that inertia. But have you given any thought to the idea that another opportunity that we might be missing is this idea of really delving more deeply into synthetic data? So Josh and I have spoken about this quite a bit. I don't know. I mean, I'd love to hear your thoughts on synthetic data. Maybe even if we can just tee it up for the audience what synthetic data is, and maybe if we can talk about perhaps a short timeline. So historically, let's call it like probabilistic synthetic data, possibly GANs, and then kind of where we find ourselves today in the large language models. But I'm saying a lot. What are your thoughts? What are your thoughts on synthetic
No,
data?
yeah, exactly. So I'm pleased that you mentioned the history where it comes from. So synthetic data, we've been using parts of synthetic data. For example, in I can give in financial services, you want to build a fraud model, but then you just do not have many instances of fraud. So you then develop synthetic fraud cases for you to train your model, your machine learning model. And I'll just say AI because AI encompasses machine learning as well. So you then create, like you mentioned, GANs. You use those generative adversarial networks. So just to give an idea to the audience around what synthetic data is, it is a technique of you creating, like it says, synthetic or fake, if I can call it in quotes, fake data. The reason why someone might want to do that is, for example, you do not have many cases of throat cancer, and you want to predict if someone who comes in does an X-ray has throat cancer. You have to train your model. If you have to train your model, you need loads and loads and loads of examples of throat cancer, but you might just not
Don't
have
have
it.
them.
So you then use those techniques of creating synthetic data, so you can create thousands and thousands of examples of throat cancer. In our case, we do not have many examples of fraud, but we want to train our model to capture even that one fraud that happens once in a while. But we
Would it
we
not be
do not have
easier
many.
just to move back to South Africa and build up your data set there?
No, yeah. South Africa, but even in SA, I'd boast to say Investec, we are really good at we're really good at our transaction monitoring. But even that one use case that goes, those are millions. Those are
Yeah.
millions that go out of the bank. So for you to train the model, you might create fake or synthetic transactional data. Then you train your model. I think the Gartner predicted that by the end of 2025, 75% of the data that AI is going to be trained on is not going to be real world data. It's going to be synthetic data. That's how important it is to AI.
So maybe just to double click a bit on the nuance there. So if I'm creating some synthetic data, and correct me as I go wrong here, I'm going to try and explain this in like really lay terms. I would try to create, let's call it like a very clearly defined demographic profile. If I were to say I'm describing a human, of an example of the thing that I need to find. Once I've defined that and built sort of these, let's call them like micro segments, I can blow them up in their prevalence so that I can then use something else to look at it and examine whether or not it gave me the outcome that I wanted. And that's where the adversarial network comes in. So you generate the data matched up to the events that you wanted to see happening. And then you have another, let's call it an agent, but this is probably pre-agents as we talk about them now. We're talking about really a model that would look to see whether or not it's good. And it has to look at that to say, yes, that was a good example of what you were trying to produce or not trying to produce, or a bad example of what you're trying to produce in the, let's call it like the bulking up of the data. Is that approximately how it works?
Yes, so for GANs, I loved GANs. They were a good piece of technology back then. So GANs is pretty much two parts. They're adversarials. You can say they're enemies. So two parts are enemies. One part is the generator. It generates. Let's the simplest example is images. So one part is generating faces of humans, and then the other part is going to predict what that image is. So that's the adversary. The adversary is just trying to, if I generate a picture of a human, the one part generates a picture of a human, the other part is going to train to say, okay, have you fooled me to say this is an actual human
Yes.
or this is a generated human. So
Right,
you're
right.
training both of training both of them. This generator is trying to fool the enemy, and the enemy is trying to catch out the generator by going through iterations of this. Generates an image, passes it on to the adversary. The adversary comes up with a predictor to say, now that is a real or a fake image. The simplest one will be, I've generated an image, part number one, passes on to the other section of the model. The section of the model will say, is it a real or a fake image? So the generator is trying to fool the second section. By doing that, where the second section cannot distinguish between a real image and a fake image, the generator would have learned how to create fake images. So that's the generative nature. Because if the generator is just passing real images, and the enemy side, the adversarial side, is predicting, yeah, this is the real image. This is the real image of a person. Then the generator is not doing well, especially if it passes a fake image, and the generator is like, this is a fake image. Passes the real image. The adversary says, this is the real image. The generator wants to know how to fake the images in such a way that the adversary cannot tell that this is a fake image.
It almost becomes an evolutionary force, refining the model towards more to become a better and better model, to generate better and better data, synthetic data. So that's effectively involvement in Spain. That's fantastic. So what is the opportunity that we can all collectively see coming out of large language models? And now we talk about a different type of agent. We could talk about like an agent as an LLM agent in the role of simulated worlds and simulating the generation of data. And I was even playing around the other day and talking to Josh about why don't we create communities? What would stop us simulating 42 million South Africans and running a sample? Let's run, rather than doing a classic poll and ask 3,000 people who they're going to vote for. Why don't we simulate that using LLMs? And the LLMs would capture all of the nuance of the context, and they'd have more variability, and there could be just quite a lot of magic that might be emergent out of that simulation that you might not find in a normal, more classic way of running these simulations. No thoughts on that?
Yeah, so that is a very hot topic right now, where they're using LLMs in agents. So one agent will have a particular role, another one will have another role, and all of that. And they're running these simulations, and those simulations are, like you're saying, creating synthetic data amongst themselves, and then they judge each other on that data. It's one area that I'm looking at for one of our use cases, where I'm looking at exactly the setup that I've just said. Just because of IP, there are certain things I cannot say, but I'm looking at agents exactly as you have described them, and giving them roles, and using large language models to say, okay, this is a starting point. This is a starting point with this data set that I'm giving you. Now go through simulations, create your own data, create your own conclusions, come up with new conclusions based on the data that you'd have created, based on the one that I've given you. And if it goes well, I'll be quite excited. But yeah, it's a very hot area right now.
Very, very exciting.
Yeah, sorry, there's some thoughts on that. There's some great simulated world experiments you can probably find on GitHub, etc., with trying to attempt a similar type of model of whether it's polling, whether it's some sort of inference of attitudes or behaviors, or introducing some intervention to a system just to simulate what that could be like post that intervention. I think the strength of GANs will come into play when one tries to obviously develop synthetic data for images. You'll obviously still use GANs in that case. Obviously, we're talking about language models, so we're talking about essentially text data and the ability to generate tabular, and in most cases, data in a corresponding manner. And I think obviously, I mean, not to pull out the obvious, but in terms of bias, etc., one will obviously have to make sure, because these large language models have been built or as essentially a sample of the internet, or almost completely Western media and information, etc. One can, through careful prompting and customization and fine-tuning, make the sort of synthetic agents more representative of your sort of population, your whatever you intend. But there's still a possibility of bias creeping in from that initial conditioning, the initial sort of training that it underwent using a completely different set of data in a different context. You know what I mean? On the flip side, GANs, from my experience, I'm sure Houston has had more success, but then I have developmentally more complicated to develop than just, you know what I mean, opening up an LLM and trying to create some sort of simulated agents with GANs. There's still some work that one needs to do depending on the framework one uses. Your point on infrastructure, or rather your point on the right talent is an interesting one. I wanted to really ask you about, what do you see as a optimal combination of skills, talents, or backgrounds to deliver on an AI solution. If I can give you some more, bring it more to life here, I obviously run an AI lab here at IQ Business, and a lot like most teams looking to expand. And when one wants to build an AI team, when one wants to build what we are calling a minimal viable team, when you talk about accessing the right talent, what do you mean in terms of the skills and expertise? What would your minimal viable team look like essentially for an effective AI team?
That's a very good question, especially in a business setting, because from my experience, what I've seen is, and not just, and this is not like where I'm currently working, but having conversations with people and seeing on discussions on LinkedIn and all of that, many data scientists, they end up sitting in IT and away from business. And there's an individual who then sits in between the data scientists, or many individuals who sit between data scientists and the business or business problem. What then happens is data scientists, they just start thinking in their own world in Python. That's all they think about now. They all think about Python. But you want data science, you want the skill, or you want the team as a whole. You have people who think about business as well. We think about the metrics of business. We think about what does it mean to be as a frontline person? What does it mean to be an ops person? If you have someone who has that skill set, and you have people in your team who know Python and who know infrastructure, because you might do, some people are good at writing Python in POC format. Right? Python, they do their models in a Jupyter notebook, do everything, hyperparameter tuning and all of that. But then how do you take it to deployment? That engineering skill set, understanding platforms like Azure and all of that, that's another, it's slightly different. It's like akin to like software engineering skill set. So having those, I would say business plus the traditional data science, which is like your machine learning skill set, and your software engineering type of skill set, those are important.
I find this a very interesting conversation to listen to. I think about the picture that emerges to me when I look at the evolution of what's going on with LLMs. There's this picture of abstraction or emergence, you might call it. Let's call it abstraction. And it seems to me inevitable that the software layer, the enablement layer of software, is going to rapidly move down to the domain of engineering. It seems inevitable to me that it's going to move away from even become more abstracted than no code. You can imagine a world not far from now where you give a prompt for a complex problem that is so abstracted as to say, I have this supply chain, optimize it. And it will be able to recursively understand what that means, run through all of the sub-processes and build it out. So, it's kind of a question of how do you build the perfect team for an unknown future? And I mean, I think it's, to me, one of the key, you've really hit the nail on the head in saying accessing the right talent, because it's an incredibly challenging problem. It's not only how do you access it, but how do you define what the right talent is?
Your last part is actually very, very interesting. Made me think when you said, yeah, instead of just accessing the right talent, it's defining what it means to be the right talent. And I think that is a debate that is there in the world. What is the talent of the future? What skill sets are going to be needed in the AI enabled future? And it's a hot topic, and a topic covers from just CEOs who are business oriented all the way to academia who study HR and skills and trends and stuff and all of that. But one skill set that I think is never going to go away is a skill set of being able to problem solve. I don't think that's going to go away. Even when you abstract and you're able to use the large language model and you can direct it, you still need to be able to problem solve. So internally here, what we've agreed on, you alluded to it in your suggestion there, where you said that it's going to, with large language models, they are not going to be as software as before with engineering because of the abstractions. On Microsoft Azure, we don't have to worry about GPUs and the infrastructure that is running the LLM. We need to just know that we can access the Azure OpenAI and how to access it and build platforms around it. That's all we need to care about. So the more this happens, the more co-pilots start coming in from Microsoft and all of that. It's how then do we enable different teams to build their own mini copilots because of their context. We're going to have all these copilots that are running around because of Microsoft. We're going to have the large language models that are going to be there. But internally, we are empowering each team. If you work in one domain, you can build a copilot for that domain that maybe you can share with the rest of the department. But as a business individual, you might not even have the skill set to do C# coding. But because of the no-code Copilot Studio, you might build a Copilot that actually works across the organization. So one skill set that I'm seeing, that concept, is problem solving. But yeah, it's it's going to be exciting. I'm not saying software engineers are going to be useless. No, that's not what I'm saying. We're definitely going to need them, but the abstraction is coming and enabling other teams to actually work with AI more than before.
I saw a REM chart of software engineers over the last 4 years past my desk today, and it looks like a mountain. It goes up and it comes straight back down. So do you think that the software engineering landscape is definitely going to change? And I'll just add something to your thoughts about the idea, and I agree with it, that problem solving will always be something that's intrinsically valuable. I have an ambivalence about whether or not that's uniquely human, or whether or not we're not going to have quite good problem solving bots as well. But there's something else which strikes me, and that's just our ability to remain awake to possibility. 18 months ago, LLMs landed and it was like a UFO had come out of the sky. It was like, how did we take this step? No one saw it coming. It's impossible. Like, I mean, everybody in the world was talking about. Chomsky was telling us why it's like not, it's just a trick, and everybody got into the fray, into the conversation. 18 months later, I mean, look, there's a lot of media about it and everybody's talking about it, but how many people are really engaging with the potential? Like, I feel that what's the fatigue that has followed, or the extent to which people have become used to this thing, which was so incredible just 5 minutes ago, is a feature that's going to separate some people from other people. The people who continue to engage and remain curious and seek out the solutions, whatever that behavioral trait is, coupled with problem solving. I think those are the things to look for. You want people who care enough to continue to engage and try to solve the problems. So you also have to have that kind of vuma.
Just a comment from our side on the topic of, before we move on to some of the other points we wanted to discuss. I was at a Microsoft event a few days ago, and they're talking about GitHub Copilot, and I took a picture of one of the big slides they took when they're talking about GitHub Copilot. It had 3 numbers. First number was 46% of all new code is now being written by AI on GitHub, and that's just, as you say, 18 months after the LLMs. And as someone who codes and uses these tools, I mean, I can't begin to express how much it's helped me accelerate my productivity, enhance the final solution, etc. And I think definitely what you touch on there, just that curiosity, that willingness to learn, whether it's an LLM or whether it's something completely different. I think that personality trait is probably going to benefit most from this sort of emerging landscape. You talk about supporting infrastructure and AI ops, etc. And I mean, I also come from the machine learning world, so to speak, although it is, almost like a Russian doll. There's AI, machine learning, deep learning, etc., within each other. But I found that personally, when I was building models, a big difference became making that shift from, just building something quick and fast in a Jupyter notebook in local environment, to then using actual DevOps principles of version control and evaluations and ML flow to make sure the metrics are sort of comparative to benchmarks, and that they're logged, etc. So that whole thing of DevOps/ML ops, as a set of practices. And I wonder what your thoughts are on this, this thing, I guess they're calling AI ops, with inverted commas, some without inverted commas. And if you play around with Azure AI Studio, which, as someone who's used a lot of open source frameworks, I've been really impressed by how much emphasis they've placed on evaluation within the AI Studio. So how much emphasis they place on comparing with the same prompt to LLM models to see what the difference in output are. Those small tweaks in evaluation and benchmarking, which at the moment I would say AI and LLM is almost in a wild west, where there's very few of such platforms like there is for ML Flow and sklearn and all of that. What's your take on sort of that on AI ops and what I've just covered there?
So when it comes to evaluations, so right now, you say it's a wild west, because you remember we started with blue back in the day. It was like this is a blue metric that you can use, but then it's now falling over. You can't even use that as an evaluation metric anymore. And then people are coming up with trustworthiness as an evaluation metric. The problem with the large language models, because they are not deterministic, or like when we used to do our supervised machine learning, you knew the ground truth and you knew what you're trying to predict. So I want to predict fraud. It's either going to be fraud or not. So you can rate how your model is performing, yes or no. 50%, 100%, you can do that. But with the large language model, the way I'm speaking right now and the point that I'm raising, someone else is going to raise the same point, but using different ways of different words, different word combinations. So how do you rate LLMs? And it's a wild west. I think people are trying to come up with proper AI ops. When you say the AI ops in quotes, I was actually thinking about saying some people, they don't think it will be possible to really reach where you can evaluate properly and then be 100% sure how your AI model is performing. But yeah, when I believe AI or evaluations, there are definitely some metrics that you can use, like on Azure AI Studio. They've built some bias. There's some bias ways to check if there's bias, ways to check if there's fairness, and all of that. They're not very explicit about how they are doing that, but on the platforms there, you can test if there's any biasness in the model itself. But it's still an active area of research to see how we can actually evaluate our models.
And I mean, you touch on something there. I think it leads into the next point about limitations quite well, because I can't recall the name of the article. I just saw it briefly on LinkedIn. I'll have to find it. But it was something to the effect of an argument that hallucinations are just, because of the point you made, hallucinations are just a part and parcel of probabilistic models, and you're not going to get away from it unless you change something fundamental about how these models are built or engage with or trained on data. And I think when you, to just the audience who aren't sure what we mean by hallucinations, that's when a large language model, any generative AI, essentially outputs something that's perhaps factually incorrect or is not tied to reality. It's made up some fact that isn't true. Essentially, an hallucination, as the term suggests. And that, I think, I mean, obviously there's research about, it's probably one of the most researched areas probably right now in LLMs. I mean, how do we mitigate against hallucinations, etc. And
Josh, maybe I could just come in there, because I think there's a subtle point here that's often lost in this discussion, which is that everything in a large language model, in a generative model, is a hallucination. So we arbitrarily determined when we say it's not a hallucination, and we become the arbiter of truth. We say that prediction corresponds to something which we say is an accurate fact. Now, that accurate fact might be a binary fact, like you've described, Houston, where you say there's an outcome which is black or white, dark or colorful, cold or warm, whatever, 0 or 1, something that's like absolutely finite, or something that conforms to a worldview that I also hold. Now, there is no such thing fundamentally intrinsic inside a large language model that where it crosses a line where it starts to hallucinate. It is always hallucinating. It is always just predicting probabilistically what the next word, series of words and phrases might be based on the associations, the proximity of the vectors that it builds itself on. So I think it's a very important point. We deem a model to hallucinate when it no longer conforms to a set of real parameters that we have on our side. Does it make sense?
I think I get what you're saying. That it is always hallucinating, but as long as it's hallucinating truthfully, okay, I would say that, because there's one point about RAG and how you can control some of those hallucinations. So I sort of get what you mean. But I think with the industry definition of hallucinations, it's when it is completely made up something that is not there. For example,
Yes,
I think it was.
But it always does. So that's the point I'm trying to land. Whether or not we see it, and I know where we're going to go to with context windows and the U-shape, which I think we was scared to, but it's important to acknowledge that everything that's generated out of these models is a prediction of something new. Maybe this point is too subtle, but it's always a hallucination. We only say it's a hallucination. I think the context that we get into now is the one where you say, if I've got another piece of information that I want to pass through it, the context window, and it retrieves something that wasn't in that context window, that's a certain type of hallucination, which is maybe where we should take the conversation. That when you're just interacting with a standard large language model, all of the outputs are a probabilistic determination of what it thinks you're going to continue in the conversation. There's no line. There's no line that says that this is now a hallucination versus not a hallucination.
Yeah, I think it's perhaps, I won't say it's a linguistic point or a matter of what you define as hallucination. I agree. Technically speaking, I agree with your point. I just think that practically we do draw that arbitrary line and say, okay, hallucination when it really deviates from some sort of a ground truth that we have previously established or that we hold to be true according to our sort of expectations, etc.
But let's get into where you were going to go, because that's actually the more important thing, which is what is the hallucination in so we talk about these context windows and put in document, and maybe just for the audience once again, you've got the large language model, which you engage with and you send a prompt into, and it returns a response to the prompt. There's something else you can do as well. You can put up a piece of information that's not inside the large a piece of a policy document or anything else that it might be. And you can then ask the large language model to tell you about that document. And inside that process, we often discover hallucinations. And there's some pretty peculiar properties that happen depending on how much information you stuff into that context window. And then there's a remedy as well, which I think is where you were going to go. Houston, do you want to talk a little bit about that remedy?
Okay, yeah. So the problem with our large language models is there's something called context length. So they can only take so many tokens, many of them. We will park Gemini on the side with their 1 million context length. But many of our large language models like OpenAI, they can only take so many tokens. I think now they are up to 32,000. I think those are the latest ones, 32,000 tokens. And a token could be a word, it could be a few characters and all of that. So let's just say 32,000 words for simplicity. But the problem now is when you want to analyze a contract, it could be more than those words. It could be more than those words. So you then say, I'm giving you something that is 200,000 words. But the way I'm going to give it this context with 200,000 words is I'm going to chunk it. I'm going to break it down into mini chunks, and I'm storing the chunks somewhere. And when I'm stored in somewhere and I'm looking for a particular clause, my code is going to go to that vector. It's called a vector store. It's going to go to that vector store, retrieve a vector that is very closest to what I'm looking for, and then pass it to the large language model. When it passes back to the large language model, it is now a chunk which has less tokens than the context length. Which makes the large language model operate well. Otherwise, if you just try force everything, the large language model, as your OpenAI will tell you, I don't have the context, I don't have the length, I don't have the number of tokens that you're looking for. So RAG, the process is called RAG, retrieval augmented generation. It works. It has worked in our use cases, and we use it very, very often. Like the one major use case that we're working on right now, it's RAG powered.
Yeah, I mean, it's a fascinating technology. And I think, I mean, you mentioned Gemini there, and I think with its at least 1.5, version 1.5, with its 1 million long context window, may obfuscate the need for RAG in some cases, but actually not quite, because of the benefits RAG introduced in terms of latency, in terms of token costs, because you pay for, a lot of people don't know, you don't just pay for what you get out of ChatGPT, you pay for what you put in as well in terms of the total token count. And yeah,
that part there is actually missed by many people, because many people, they are excited that it's 1 million tokens for Gemini, but they are not accounting that you're actually putting the whole Harry Potter series into Gemini just for you to answer who was agreed. Yeah. And now you're paying for all these tokens that you have put in there and that you have processed in that, instead of just RAGing where you are putting you're processing few tokens. But yeah, that's a very interesting one. I hadn't thought about that one, but Thanks for highlighting it.
Yeah, and it's been a really fascinating conversation. I think we touched on. I mean, I think your article was a great one. I think there's a lot of identification that I have with it from my own experiences building the generative AI solutions. And so, yeah, fascinating conversation, and really grateful for you joining us, Houston. I think it's been, the time flew by, but it's been a really great conversation. Hoping the audience has learned a lot about the sort of use cases, how to go about it, on the challenges, how can they go about it, addressing that in their enterprises. And yeah, so thank you very much, Houston, and thanks to our listeners for joining.
Yeah, thank you so much, and it was a great time.
Wonderful to have you, and we'll continue to follow you on LinkedIn, and we really appreciate your time today.